This is the second part of lesson 2.3, similar triangle proportionality. Okay, example number 7 in your homework or in your notes, we are going to find whether or not these two triangles are similar. So I'm trying to find out if triangle ABC is similar to triangle EDC, and that's the question I don't know. So how could I figure that out? So look at what we're given. We're given that these two angles are the same. Okay, great. So we've got one angle. That's not enough. What else do I know? Okay, if you look at this, hopefully you saw you've got two vertical angles. So I'm going to say that angle A is congruent to angle E, and that was given. And I'm going to say that angle BCA is congruent to angle ECD, and that's because they're vertical angles. And so because of that, triangle ABC is similar to triangle EDC because of angle-angle similarity. So for your homework, you're going to have to tell whether they are or not, give a similarity statement, and tell me the reason why. So one of the three reasons that we saw in the previous video that's just right up above there, either angle-angle similarity, side-side-side similarity, or side-angle-side similarity. Okay, example 8, same thing. Are these two triangles similar? So we're given one angle in each of them, and so we don't have any other information on angles, so I'm not going to be able to use angle-angle similarity. I do, however, have a side and a side on either side of the angle, so side-angle-side is what I'm thinking I'm going to do. So what I have to do is check and see if everything is proportional. So if 7 to 14 equals 10 to 20, then that's the same proportion. Is 7 to 14 equal to 10 to 20? Yes. And so because of that, we've got a side, an angle, and a side that are proportional. Well, the angle is congruent, the sides are proportional. And so we can say that triangle FEG is similar to triangle LKM because of side-angle-side similarity. Okay, in example 9, which of the following three triangles are similar? So if we call this triangle A, triangle B, triangle C, which of those three are similar? So we don't have any information about angles at all. So we're looking at side-side-side similarity. So if you say that any two are similar, all three sides for each triangle will have to be proportional. So let's take the first two. I could take the largest side, which is 18, and compare it to the largest side of the other triangle, which is 7. The medium side, which is 15 and 5, and then the smallest side, which is 6 and 3. Are those all equal to each other? Hopefully that's pretty easy to see that they're not. So A and B are not similar. Okay, then I'm going to try these two. Okay, so I'm going to take, again, I can take the shortest side compared to the shortest side, the medium side compared to the medium side, and the largest side compared to the largest side. Are those the same? Are those equal in proportion? And hopefully, again, you can see really quickly that they're not. So A and C are not, or B and C are not similar. What about A and C? So if I'm going to look at A and C, so I'm going to take the largest side to the largest side, the medium side to the medium side, and the smallest side to the smallest side. So are those similar? I mean, equal in proportion. So if I look at my fractions, 18 over 30, that's going to be 3 over 5, and 15 over 25 is going to be 3 over 5, and 6 over 10 is 3 over 5. So those are, so we're going to say that triangle ABC is similar to triangle GHI, and that's because of side-side-side similarity. Okay, number 10. Identify the similar triangles. So in other words, give me a statement. Triangle blank is similar to triangle blank. So that's what you're going to tell me. So you have to match everything up the right way. So since two angles are marked, I can use angle-angle similarity. And so you think this one's going to go there. So I'd have A and H. And this one's going to go with that one. So I could have C and J. And then I just throw the last one on there, B and G. And so those are my two similar triangles, and that's because of angle-angle similarity. The next thing I have to do is find x in the measures of the indicated sides. So because the two triangles are similar, I can write a proportion. So I can say x plus 1 to 3 is equal to x plus 5 to 6. Using my cross products, 6 times x plus 1 equals 3 times x plus 5. 6x plus 6 equals 3x plus 15. Subtract 3x from both sides. So 3x plus 6 equals 15. Subtract 6 from both sides. And so x is equal to 3. So the question, find x, which is 3, and the measure of the indicated side. So 3 plus 1 is 4, and 3 plus 5 is 8. So 4 to 8 equals 3 to 6, which sounds great. Okay, let's go to the application problems on the last page. So these are the most common types of application problems you'll see with similar triangles, and that's like using shadows or reflections on mirrors or something like that to measure distances. So it says a meter stick. Okay, quick question. How long is a meter stick? It casts a shadow 65 centimeters long. I've got two different measurements, so I've got to decide what am I going to use, meters or centimeters. Make up your mind, decide, it doesn't matter, but just make up your mind. At the same time, a tree casts a shadow 2.6 meters long. So we've got the tree, which we would probably be better off measuring that in meters, and it's casting a shadow that's 2.6 meters. We've got a meter stick, which is 1 meter, and 65 centimeters. So how many meters is 65 centimeters? So this is going back to your remembrance about centimeters and meters and the conversion. So 65 centimeters is 0.65 meters, and that's what we're going to use. So I'll just give you a hint that there's a question on your homework where you have to do that, so make sure you're paying attention. Okay, so just set up our proportion. Both the meter stick and the tree are standing straight up. The sun is shining at the same angle for both of them. And so these are similar triangles because of angle-angle similarity. So we can just write a proportion. I can say 1 over 0.65 is equal to x over 2.6 and solve it. So you can use cross product. So 2.6 is equal to 0.65x. Divide both sides by 0.65. And you get how tall the tree is. So 40 what? 40 meters. Okay, the next question is another type of problem. It says finding the distance across a canyon can also be difficult. So basically our canyon is from R to D, and so if you visualize like a big canyon, so you can't like jump across it and measure across. And so what you can do is you could, be here on the side of the canyon and measure to the edge of the canyon, and be over here and measure to the edge and measure to there. So you can do these measurements. The measure you can't make is that one. So you can find that length using similar triangles. So what we do is we just think, okay, well, first of all, are they similar triangles? How would I prove it? Well, they've both got a 90-degree angle. We've got vertical angles are the same, so angle-angle similarity. So all you have to do is set up a proportion. So x to 35 is equal to what? Pause the video, write your proportion, and then go ahead and solve it. So if you write x to 35, you're going to write 144 to 60. And when you do your cross products, you're going to get 60x is equal to 5,040. Divide both sides by 60 and you get 84. So going back, this is 84 right there. And so then you could find out, using the Pythagorean theorem, you could find out how long that is and how long that is. And you could find your distance across a canyon. So it just says, use the diagram to determine AR, which is x. And then that should say, and the distance across the canyon. So the distance across the canyon, I'll do the shorter length first. I'm going to say 84 squared plus 35 squared equals x squared. And then I'm going to do 60 squared plus 144 squared equals y squared. And when I get x and y, I'm going to add them together, and that will be my distance across the canyon. So pause the video if you haven't already figured that out, and figure out what that distance is going to be. Okay, the distance across the canyon is 247 meters. Okay, the next question, a flat-roofed garage casts a shadow that is 9 meters long. So I'm going to start by drawing a picture. A flat-roofed garage, we've got a shadow that's 9 meters long. At the same time, a 1.8 meter lamppost casts a shadow that's only 2.7. So the lamppost is shorter than the garage. I can tell that because the shadow is shorter. So the shadow, if the lamppost is 1.8 meters, the shadow is 2.7 meters. And so I can find how tall the garage is by setting up a proportion. So pause the video and set up your proportion and find out how tall the garage is. Okay, the garage is 6 meters tall. Make sure you label your answers. Okay, last question. A 12-foot statue casts a shadow that is 5 feet long. So let's Sarah's statue is 12 feet and 5 foot long shadow. At the same time, a fence post casts a shadow that is 1.25 feet long. Okay, so it doesn't have to be fancy. What is the height of the fence post? And so the reason why these are similar triangles is because the sun is shining at the same angle for both of them, and they're both hopefully standing straight up. So pause the video, write your proportion, and solve the question. So this means that the fence is 3 feet tall. Okay, this is the last of the lesson. I want to emphasize on the triangle or the angle bisector theorem that we did in the previous video. That is something that you need to study and be familiar with how that proof works, because it's very possible that you will see that again. So please make sure that you study through that, and you can listen to it again if you want to, but study through the proof and make sure you know what you would do to do that proof. You should now make sure that your notes are done and get your homework.